I had this dream of winning Battle of the Builders Young Guns. I had seen that at SEMA, and I was talking to my dad about it, and I'm like, I want to do a tube front end, and I'm thinking about doing it from shock tower forward, pretty much like every FD car. And then I'm like, okay, that's so limiting. And he's like, oh, you got it. Just cut the whole thing off. And then really, honestly, the next day, I built a jig and just sawzalled the entire front of the car off.
Welcome to the HPA Tune-In podcast. I'm Andre, your host, and in this episode, we're joined by Cam Kokalis. And if you haven't heard that name, Cam is the builder of one of the wildest 8.6s that I've seen. And that's saying something because, let's be honest, the current generation of 8.6 has become incredibly popular for modifying, and I've probably lost count of how many Rocket Bunny wide-body kits I've seen sitting on three-piece wheels and airbags, which is actually exactly where Cam's car journey with the 8.6 started. However, it really escalated from there, and this car was entered in the SEMA Battle of the Builders competition, which is a very fiercely fought battle indeed, some of the most insane machinery that you're likely to see. The most impressive part, I think, is not necessarily the car that Cam has built, but the fact that, as of this interview, he is just 22 years of age. He bought this car when he was 17, and over that period of time, he has basically constructed a full tube frame car with some amazing features. The other impressive part here, he was 100% self-taught. So this interview with Cam really made me come away feeling like I've been lazy my whole life. The amount that he has achieved in such a short time should be inspirational to those who are out there thinking that they want to take on a fabrication project, but maybe they don't have the skills that they need. Cam will show that there is no excuse here. We'll also talk about the equipment necessary to do fabrication at the level Cam is working at. And you may be surprised to know that he's only into this for somewhere in the region of about $3,500 US. So again, if you're using money for tools as an excuse, that one, I'm sorry to say, is off the table. Before we get into our interview with Cam, though, for those who are new to the Tune-In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune engines, build engines, construct wiring harnesses. We also cover fabrication topics, race car setup, race driver education, and data analysis. You can find all of our courses at hpacademy.com/courses if you do want to know more. All of our courses are delivered via high-definition video-based modules that you can take from anywhere in the world, provided you've got an internet connection. This gives you the benefit of being able to learn at your own place and at your own pace. All of our courses also come with a 60-day no questions asked money back guarantee. So if you purchase and for any reason at all decide that it's not quite right for you, no problem, let us know. You'll get a full refund of the purchase price. And as a podcast listener, you can use the coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. We'll put a link to that coupon code and our courses page in the show notes. All right, let's get into our interview now. All right, Cam, welcome to the podcast. Thanks for joining us. And as we always do, I want to start by learning a little bit about your background and specifically how you developed an interest in cars.
Yeah, thank you for having me. My name is Cameron Kokalis. I am a completely self-taught welder, fabricator, and car builder. Kind of do everything. I learned how to paint, wire, fabricate, everything on this one car that everybody kind of knows me for. It is a full tube chassis LS3 swapped 86 with like a crazy 8-to-1 header. We're going to go into detail on the whole thing, but yeah, that's kind of like me in a nutshell.
Okay, well that's the 2-second, 30,000 foot view of your life. In terms of developing that passion for cars, I mean, was the 8.6 kind of the first car you bought and decided to dive into the world of modification on?
Yeah, so the 86 was my first car, but it's a very like kind of teenager dream car where when I was 13, 14, I think maybe I was 13 or 14 when that car came out, and everybody started wide bodying them and doing all this stuff. And I was like, wow, I want to do that. I want to have a wide body bagged 86 with 3-piece wheels. That was my dream. And I had saved up all my money, bought the car, and started kind of going down that process. And that was really the first stage of the build, was getting into learning how to do the wide body, the wheels, the bags. And at that point, that was like so scary to me. I had never done anything with cars. My family really is not into cars. They are the type of people that get a car at a dealership and then get a new car when it hits like 150,000 miles and always take it to a dealership.
So I'm interested there if that sort of skill set and the passion for cars didn't kind of come from family, which is quite often the way. Is this kind of driven by the friends you're hanging around with as a teenager?
I mean, we would talk about cars like they look cool and like it would be cool to have these cars, but it was never like this overwhelming, like all of us were into cars. It was really me, and I was very much into art, like traditional painting, drawing, all that. And I had gone through the process of that, and I felt like maxed out what I could do with that and my skill set. And it almost had become boring, where like I paint something and I'm like, okay, this is it. And I had all this math knowledge and this drive to do something more complicated. And then when I finally had purchased that car and kind of started in that process, I'm like, wow, there's engine, there's aesthetics, there's chassis, and you can just go 100% in all these different areas where you can make a project go for like years on end and have all this complexity that like normal art can never have. And I love that.
Yeah, absolutely. There is so much room for sort of expression in the automotive scene, which is interesting that you chose the 86. I mean, it is an incredibly popular car, and I've got a dog in that fight because we have an 86 as an endurance race car, so I absolutely love that car. It is, however, a very popular car in the aftermarket scene, which means that it is also very, very difficult to stand out from the crowd. You know, the Rocket Bunny wide body kits, bags, three-piece wheels, all of that stuff has been done and dare I say it, done to death. When you're looking at your options, did you sort of look at, well, what can I do that's going to be stand out and make it different from the rest? And I mean, clearly at this point, that's exactly what you've achieved, but I understand that project also developed over time.
Yeah, so at that point, I didn't care. I was like, I will be that. I will be the wide body bagged 86 and I will be completely happy. And I did go down that process. And for about 6 months, I had a wide body bagged 86 that was just as stereotypical as it gets. It was on these bright teal wheels. And then I had met his name's Jeff from Full Race Motorsports out in Arizona. And he had given me the opportunity to actually go out to SEMA in 2019. And at that point, that's all I knew was the wide body bag thing. I went to SEMA and my eyes were completely opened. I was like, wow, people are making these cars that are so unique and so artistic. And I've limited myself here. I don't have the skill set yet, but it really just opened my eyes to what I could do. And I was like, okay, the vision has changed. I no longer want that stereotypical 86. I want to build up this skill set and build something that is art, honestly.
So it was the light bulb moment for you at SEMA, just seeing what other people were doing and how extreme some of those builds were.
Yeah, and there was this green Live to Offend E30 with a equal length 8-to-1 header. And I saw that and I was like, oh my God, that header is the most beautiful thing I'd ever seen in my life. And I wanted to almost design a car around that header. So I took the collector, and my design of the header is actually quite different than the one that I saw at SEMA. But that header is kind of what made the rest of the car get as crazy as the header to kind of match it.
Yeah, definitely. I mean, it is a standout element and it does make the car. Let's roll back a little bit. So coming back from SEMA 2019, I think you mentioned, and at this stage, I'm guessing you've still got your traditional wide body airbagged 86. So what was the plan at that point? What did you decide you wanted to do with it?
Yeah, so I had made a plan that I was like, okay, the first stage of that is going to be me learning to TIG weld and weld the interior cage, because just a good first step is like strip the interior, make the interior look beautiful with a full like 8-point FD spec roll cage. So I had done little projects like with fiberglass and ABS plastic to just try to kind of start getting my almost like 3-dimensional design work better. And then when I moved off to college, I think it was a year later, I got a little like 450 square foot storage unit shop. and I purchased a Vulcan welder. It's this little Vulcan TIG welder, and that is what my whole car has been built with. But it was a relatively cheap machine that I've done some upgrades to. But I taught myself to TIG weld using YouTube and forums and really anybody on Instagram that would talk to me and give me insight.
Nice. Tell us about that journey of learning, because TIG welding is a pretty specific skill. And as I see it, there's two parts to it. There is the technical knowledge of how you need to set up the welder for a certain material. And then there's also the technique, which just simply requires practice and time on the torch. So how did you learn that? Because you've said you used YouTube and forums. YouTube is an amazing resource, and there's just about all of the world's information out there. But one of the problems I found, and one of the reasons why we founded High Performance Academy, is when you're looking at something technical like that, there'll be thousands, hundreds of thousands of videos that you could watch. And there's a lot of videos, maybe more videos than not, are going to not necessarily be factually correct and maybe send you sort of down the wrong path or give you bad information. So how did you go about sort of fact from fiction with those YouTube videos?
Yeah, so obviously when you're starting off and you have zero skill, you're very impressionable, and you're really going to try anything that somebody on YouTube is telling you that you should try. So I started out with getting 1/8-inch plate and just running bead after bead after bead flat on the plate. And when I started, it looked like bird poop, honestly. Like that is the closest thing it resembled. And I'd keep going, and I'd start getting my consistency down for bead width and all that. But it was still just completely gray and overheated, and the technique just wasn't right. So that's really where YouTube came in, and just sifting through videos, like somebody would say, do this with your gas, or do this with the torch angle, or your cup size, or whatever it is. And I would try it. And then if it worked or helped, great. If it didn't, then I'd kind of disregard it. And I sifted through all that and found a technique, a torch setup, a cup size, gas, all that worked perfect for me. And eventually on that same plate, I could run a bead that had beautiful color, beautiful spacing, perfect penetration. And then I moved on to round tube practice. And once I could do the same with consistency and coloring on round tube, that's when I actually took the step to build the roll cage, because I just didn't want to build a full TIG welded roll cage that was not correctly TIG welded. That's like the worst thing you could do.
Yeah, naturally. All right, so there's a lot to unpack here, because we've talked really briefly about TIG welding, but I mean, building a roll cage also involves bending the tube for a start, and then notching the tube. And particularly when you're using the technique of TIG instead of MIG, there's not really anywhere to hide with your notching. You can't really fill big gaps. So fit up is really paramount. So on that side of things, the tube bending and notching and the general design of the roll cage, how did you sort of formulate those skills?
Yeah, so kind of just the basics. I purchased a super cheap tube notcher. I think it was about $100, and a manual tube bender. Those are the two tools I built the whole roll cage with. And I kind of have a good skill of using templates and using multiple steps to almost cheat not having the skill. So like where I want to make the main hoop, I would make a cardboard template of what it needed to be. I would make an individual bend that had my bend line on it, and then I would match it up so I knew like the widths between my bends and what I needed to do to get perfect fitment in the car. And then when you do stuff like that, you end up with a perfectly fitting tube. And then honestly, the hardest tube on a roll cage is the A-pillar bar on a full cage. And that way I cheated it pretty much the maximum. I used little straight sections of tube and little bent sections of tube. I put it in the car and tacked them together. So I knew what planes my bends were on and how much it needed to be bent.
Sure.
And then I just made a copy of it, basically.
Okay. Yeah, well, that makes a lot of sense, because as you mentioned there, I mean, that A-pillar bar, the complexity is you've got multiple bends, but also not necessarily in the single plane. So very, very easy to get that dramatically wrong. And I sound like I'm speaking from experience, but believe me, I've never built a roll cage in my life. I have, however, worked alongside a number of people who have done that for us, so I kind of know what's involved. Another element with roll cage design and building is consideration of like how you're going to get access to full 360-degree weld each of the tubes. So can you talk to us about the options available for doing that?
Yeah, so on my front base plates, I had tacked them into the car. But once you removed those, the bars could drop down past the side frame rails. So that basically allowed the front to tip down when you broke the tacks on those. And then the rear base plate sat kind of up in the rear seat section. And by dropping the front down, you could scoot it off of the rear seat section. And then that dropped the rear down. And then you could get, with the windshield front and rear out, you could get completely around it.
These would be quite important considerations early on in the design process, though, so you don't kind of build yourself into a corner, correct?
Yeah, to a certain degree, it's balancing how tight you can get the roll cage to how much movement you need to weld it, whether that's taking the roof off too to get the cage tighter. You can do things like that, but definitely on specifically my A-pillar bars down by the dashboard, I added a little gap in the car so that those could drop down and make it without kind of locking it in place once it was all like a structure.
Sure. Okay. In terms of the regulations in the US for building roll cages for certain types of motorsport, is there anything around a requirement for a qualification, or can anyone such as yourself build a cage and as long as it passes a visual inspection, you're good to go?
Yeah, so there is a tool that measures the thickness of metal, and specifically on TIG welds, you have a minimum undercut that you can have. So if the weld has not had enough filler wire and it is getting too thin, there is a tool that can check that. And as long as there's no visible undercut I think there's a minimum that it can have, and then there's a specific thickness, you don't have to have any specific TIG welding certifications to build a roll cage like that, I believe, for most motorsports in America.
Okay. I mean, that's definitely the same here in New Zealand, with the exception of if you're building out a chromoly, it's a little bit fussier. But obviously, the rules are different in different countries. But point being here, I think most people assume that you have to take your car to a professional fabricator if you want a cage. And as you've obviously just proven, it's definitely something that if you're prepared to put the time in, it is a skill that you can learn. In terms of the required tools, you mentioned you bought a tube notcher for about $100. You've got your TIG welder, obviously. The other key element there is the actual tube bender, and these are quite specific for roll cages because we don't want to crush the bends. Here in New Zealand, again, they have a specification in terms of across the bend, how much it can be crushed. So the dimensions and perpendicular to each other, and it must meet that. So the type of roll cage bender is important. What sort of money do you need to put into a suitable roll cage bender?
Yeah, so I have a Pro Tools 205 roll cage bender. It's just a manual bender. And I believe the base bender is about $500, or it was when I purchased it. And then you have to get the dies. So I have 4.5-inch tubing, which is what my roll cage is, a 4.5 and a 6-inch radius die. And I believe the dies, you could get them for about $150 a piece. So like maybe for the whole setup, you're talking $850 for a really nice solid bender.
So aside from the TIG welder itself, you're into this for under $1,000 basically to be able to build your cage.
Yeah, and even my TIG welder with the Vulcan from Harbor Freight, when I bought that, it was like $900. So my TIG welder, my little super cheap notcher, and the tube bender, it's a very reasonable project to take on, honestly.
Yeah, and again, I think a lot of people would expect that they A, can't build a roll cage for the reasons I just mentioned, and B, that they're going to need thousands of dollars worth of equipment in order to do so. So great to break that down. Obviously, it's still not a task that everyone's likely to want to jump into, and I mean, particularly for competition cars, if you aren't confident with your ability to design and safely weld the cage, then, it is a safety aspect. So yeah, you're best to leave that to someone else. In terms of material selection, I just mentioned chromoly before. What did you use for this cage?
Yeah, so the cage and the whole chassis is DOM mild steel, so seamless mild steel. It's almost equivalent to chromoly if you go slightly thicker. So it's just a seamless tube that's mild steel versus chromoly. Although I can say chromoly is way more fun to weld, and I've switched to that completely.
Okay, in terms of way more fun, can you sort of expand on that a bit?
Yeah, so mild steel is a very dirty material. Just when you're specifically, just a quick background on TIG welding, it has to be almost surgical clean when you're welding it. So it has to be wiped down with acetone. You got to wipe down your filler wire. So when you're welding something like the factory car metal, it's very dirty and you almost can't even TIG weld it. Mild steel is very TIG weldable, but it is a dirtier metal. So you're going to have more stuff coming up in the weld pool, but chromoly, just for TIG welding, lends itself very well. It's very clean. It is very consistent in what it does, and it's just easier to weld, I think.
Sure. Okay. I mean, in terms of those two materials as well, if you're looking at the choice between them, chromoly generally it's a higher strength. So basically, if we're talking about roll cage tubing, for example, you can end up using a thinner wall section compared to mild steel. So ultimately, the benefit there for motorsport applications is that the finished roll cage or structure that you're making ends up lighter, but still just as strong. Caveat there is that really you have to TIG weld when you're using chromoly because of the heat affected zone. Basically, if you were MIG welding it, you'd overheat it and it becomes brittle in the weld area. So that is a consideration there. I'm guessing in your application here, you weren't so worried about weight anyway, so mild steel made sense.
So, yeah, my car is really an art project and it's really to create a vision, but my whole chassis is 0.12 wall DOM. And then, for instance, I built a full E30 chassis that is 0.095, so a chromoly. So basically, 0.12 DOM mild steel is equivalent almost to 0.095 chromoly.
So, I mean, there's going to be a weight saving. I mean, it is also worth mentioning that that weight saving is still relatively minor in the big scheme of things. But of course, for motorsport, every gram or every ounce is going to make a difference. Okay, in terms of TIG welding as well, you've talked about mild steel and you've talked about the chromoly. Obviously, the flexibility of TIG welding, if you've got an AC/DC machine, is that you can also weld non-ferrous materials, aluminium. That one there, at least with my very limited amount of TIG welding I've done, getting really nice weld porn worthy beads on aluminium is tricky. Have you found the same, and is there any tricks and tips you can give us there?
Yeah, so I personally do not like welding aluminum. I've gotten quite good at it, but I do not like welding it. It's very finicky. So the frequency, the gas that you're putting into it, and even just how you've grinded your tungsten all makes a huge difference in like it. Aluminum is honestly the dirtiest of all of the metals just because it actually needs the cleaning action of the AC to be able to even weld it. It just brings up so much char that it is a very hard material to weld. But yes, once you get all the settings perfect, specifically the frequency and the percent of cleaning action, you can get very solid aluminum welds. And like I figured it out, you can figure it out, but it is difficult.
Yeah, I think, again, I'm absolutely no pro here. I think it's one of those things that if you want to be able to lay down, that nice stacked dime bead of weld-on alloy, you just need to put in hours and hours of practice once you've actually got those settings dialed in. But that's where it's that sort of double-edged sword, because if you haven't got the settings right, no amount of practice is going to get you the results you're looking for. So, researching and understanding what the settings do and how you need to adjust them for a certain material and thickness of material, that's obviously the first place to get started. All right, so coming back to the build on the car, at this point you've got an 8-point cage welded into it, so your skills are obviously progressing. At what point did it seem like a great idea to cut the front off?
Okay, so yeah, like I said, the plan was to have a wide body bagged 3-piece wheel caged 86. That was like, okay, I'm gonna kind of expand it a little bit. But I was like, okay, I had this dream of winning Battle of the Builders Young Guns. That I had seen that at SEMA, and also revealing a car in Toyo Tread Pass at SEMA, because that was quite possibly the coolest collection of cars I had ever seen. So I was like, okay, I need to build something that's really going to push the limits here. And I was talking to my dad about it, and I'm like, I want to do a tube front end, and I'm thinking about doing it from shock tower forward, pretty much like every FD car. And then I'm like, okay, that's so limiting. And he's like, oh, you got it. Just cut the whole thing off. I'm like, okay. And then really, honestly, the next day, I built a jig of the shock tower mount points, the lower suspension mounting points, and just sawzalled the entire front of the car off, not looking back.
So basically, jump out of the plane and build your parachute on the way down.
Yeah.
Yeah. Okay. I mean, it's one way to achieve it. So that jig, it was important to you to not have to essentially reinvent the wheel. So you wanted to work with the existing suspension geometry. And I guess that allowed you then to also retain a lot of those factory parts, or at least aftermarket replacement factory parts for the likes of struts and lower control arms, etc. Were there any changes that you made in terms of having that flexibility to basically put everything wherever you wanted it?
Yeah, so basically by recreating the whole thing, I did move the shock towers wider. So that would allow me more clearance for the header, because the V8 plus the header is actually really wide. And then a big problem on the 86 platform is with a bag, it rubs on the inside of the strut tower and it can rub through the bag. So by bringing it out further, it gave more clearance for the bag, and it gave more clearance for the engine. The other thing is by pushing the shock towers slightly back, I found that it helped me with wheel clearance with the wide body and just made the car feel way more solid with a wide body setup. I mean, I'm talking minuscule amounts on what I actually pushed it back. I think I pushed it back about a half an inch. But yeah, the car actually still utilizes the factory strut, and we've redesigned all the suspension with a company called FDF Fab that I worked with. So it has an angle kit and it's all redesigned, but you could bolt on stock lowers, stock struts, everything, and have it be completely functional. And by doing that, it really let me go crazy with the artistic element and not worry about what I was actually doing functionally.
I'm interested with that flexibility to do essentially whatever you wanted. Was there a consideration to go a little bit more crazy with that front suspension design and maybe ditch the McPherson strut and go double wishbone or a push rod actuation cantilever like you've done in the rear? Or yeah, what was the impetus behind sticking to stock based parts?
Yeah, so I didn't have a ton of confidence, honestly, with suspension design and even the difference between those, how to utilize the I believe that dual wishbone is far superior. When I built my E30 chassis, it is utilizing that on all four corners. But at that point in my journey, I really had no knowledge on what needed to happen suspension-wise, and I just wanted to build something for the art of it. But by the time I had built the front, then I built the rear, and I had then messed with suspension enough.
Skill set had improved.
Yeah, the jigs and kind of doing the research from suspension books and just information books and talking to people to understand how it works, that I'm like, okay, I want to go a little crazier in the rear to push my skill set and learn some more.
With a project like this, I mean, that's a classic example. I kind of had a project car back in my early days, absolutely nothing of the level that you're doing. But what I found myself constantly falling into the trap of, I'd do a part, let's say, for your example, the front suspension, and then I'd work on another part of the car, make that part better. So let's say your rear suspension, which we'll talk about in more detail, but a more exotic cantilever design. And then, I'd sort of sit back and go, well, shit, now that front, it's not as good as it could be. So you kind of get into, it's very easy to get into that trap of constantly iteratively improving parts rather than just actually getting the car complete and finished. And I know that's a trap that a lot of car builders do fall into, just basically never being entirely satisfied with what they've done and just constantly iterating improvements. So how did you sort of just knuckle down and nope, light at the end of the tunnel, I can see it, we're going for it?
Yeah. So on the whole car, I never redid anything. So everything was done once, but I am very meticulous and OCD about how I do things, where I would build the front end and I researched for hours and hours and hours to get all the knowledge I could to make it visually work perfect, and putting wheels back on and checking for turning radius and designing tubes in a way that it would support the fenders and fit the headlights and all this stuff. So before I even designed and put in a single tube, there was so much research into where those tubes needed to go, how they were going to look, what they needed to do, so that when I actually did that, it was at the level that a professional would be doing it, where everything was taken into consideration, it was thought through, and then I did it once, did it how I intended it to be done, and then I'm like, okay, this really can't be any better. It's how I want it to be and how it can be, really.
I mean, I think that also highlights the importance on a project of this magnitude of how important the planning stage is, trying to think through every element. Now, these days, we would most likely see a build of this level rely heavily on being built virtually in CAD, so that you can go through all of that design process, basically build the car up and make sure that your headers are going to clear, the suspension clears, etc. You did this the old-fashioned way, as I understand it, analog. Is CAD something that's on your sort of radar to sort of develop your skills there as well? Do you see benefits?
Absolutely. I have learned now, since pretty much right after I finished the car, the basics of both Fusion 360 and SolidWorks. Because first off, every single bracket on that whole car was cut with an angle grinder. And that was not easy or a good use of time. So just by learning the basics of one of those softwares, I can whip up a bracket that fits perfect and tolerances are perfect in like 30 seconds, and then send it to Send Cut Send. You get it in a couple days and you're good. But really, you can do it with just kind of using reference measurements is how I go about it. So if you have a jig that you've built off the stock thing, or the stock car and the mounting points, and you've left off mounting points of that, you can triangulate points in thin air, basically, to go from one point to another to get a point in space. And then when you go about building the tube structure, when you build one side, you take that tube off and you build an exact mirror copy, 2 notches and everything. And then when you mirror copy every single tube and it fits within the jig, usually there's one last tube where everything can kind of move around, and until that tube is in, everything can move. And if that last tube matches and it fits within the jig perfectly, then each side is perfect. It's symmetrical, and it's going to do what it needs to do. And that's really the process that I use to go about that.
Yeah, there's a couple of things I want to kind of point out to our listeners here. So I think these days, because anyone who's sort of scrolling car builder accounts on Instagram is probably seeing the use of 3D modeling and CAD, it's everywhere. And yes, there absolutely are some advantages, but I just want to point out if people are using their lack of knowledge in CAD as a reason to hold back, you're a perfect example that absolutely it can be done without that technology. The other point I wanted to make there, people again see SolidWorks and Fusion 360 being used for these elaborate projects, modeling a full car and every single component in it, which absolutely, yes, you can do that. But I mean, at its simplest level, what you mentioned there is just using the sheet metal working functions within those software packages to design brackets, and then just email that file through to the likes of Send Cut Send, and you get the parts back. They're going to be better. They're going to fit just like you expect them to. And particularly if you're doing multiple brackets, like the time saving for the relatively small outlay for a superior product, it's just an absolute no-brainer. I mean, I wish I had access to that technology back years and years ago when I was building my drag car, but I was like you, angle grinder for all of the brackets. Mine didn't come out quite as nice as yours though.
Yeah, like if I had just taken like a day and a half, 2 days, I could have got that amount of knowledge in the beginning of this project. It's just like that 3D software was such a mental block because it seemed so like out of my comfort zone. But it could have saved, like, I'm talking hundreds of hours on the amount of brackets on this car. And it just gives you one more thing. Like when you make that bracket and you know the bolt hole is the exact tolerance, you can use that as another reference point, because it's not a janky bracket that has tilt. It's going to fit against the tube. It's going to be a very solid reference point where you can use it for other things. That's the biggest thing, honestly.
And I think On that point there as well, it's always hard to sort of justify, I'm going to stop my project, I'm going to stop physically working on this car where I'm seeing every hour I put into it, there's progress, I'm getting further along. I'm going to stop that, I'm going to park that whole project, and I'm going to spend a week or whatever it's going to take to learn 3D modeling in CAD. It's hard to justify spending that time because you don't know at that point like how much that is going to save you as the project progresses. But I mean, that's just a natural progression, I think, anyway. Another element I'll just bring in here, a little anecdote from our own workshop, and we've got a little Honda CRX race car which has got a K20 swap in it, and we're just going through the process of a bit of a redesign of the front end of that. So one of the things we wanted to do was move the engine back in the engine bay. The engine location had been compromised due to brake master cylinders which we'd moved, so we could move it back I think it was about 100 mil, maybe a bit more. We had the opportunity there. My guys scanned the engine bay, scanned the engine and the gearbox, and basically could build it virtually. So we moved it back and then went through a process using another software package called Optimum G of modeling the suspension pickups and how those would change. One of the challenges was that when we moved the engine back, we also needed to move the steering column, and that actually caused some serious issues with bump steer. So by modeling it in Fusion 360, finding out where the steering rack could go, and then basically putting all of those points into Optimum G and modeling the suspension kinematics, straight away we found that if we moved the engine back to that location and the steering rack was in the only location it could be, we would have some insane bump steer that there was absolutely no way of rectifying. So ultimately, we went round in circles and ended up almost back where we were. But the flip side of that is if we didn't go through that process, we would have wasted a hell of a lot more time and a hell of a lot more money moving the engine back and then finding that the bump steer was unrecoverable. So embracing these technologies is an absolute time saver.
Yeah, absolutely.
Right. In terms of engine selection for the car, was obviously the whole car was kind of designed around that 8-1 header concept and the visual, the aesthetic that gave. So obviously it was going to be a V8. The FA20 probably not going to cut it.
I mean, they just don't sound cool either. They're overly complicated and really no way to hide wiring. Not a lot you can do fabrication wise, but the biggest thing with V8s, really any V8, is it gives you so much freedom to fabricate and create art, because the engines on their own are so simple. Like you can strip down an LS to the point it only has an alternator running on it, which is how mine is running. It just has an alternator and it just looks like a block sitting there, but it's running completely functionally. And then you can use that and just build around it. And that's really what LS in particular I chose, because the simplicity, the research, just the YouTube videos and knowledge that is on that engine is endless. And the horsepower per dollar, like you can get 525 horsepower is what my engine makes. And that it's an LS3, 525 horsepower, and overall a very cheap, very nice aluminum block engine, that just works.
Yeah, no, you're right. I think the simplicity of that pushrod V8 design, obviously the pushrod design means the cylinder heads are smaller. And I mean, you put that side by side with a modern quad cam V8, let's say Nissan VK56, just as an example. I mean, it is physically a monstrous sized engine and a lot more going on. So I think if you're looking at it as essentially an art project, which this is, that would take away from that aesthetic. Obviously the LS, you could argue, is also a pretty played out engine swap. They're just about in everything and anything. Was there any other options that you were considering, or was that always the go-to?
I was actually considering a 2J. It was between a 2J and an LS. I was either going to build a crazy twin turbo kit or a crazy 8-1 header. I ultimately decided that 2Js had so many different parts on the engine that I couldn't visually make it as concise and clean as I wanted it to. And for anybody that's ever seen my car in person, and especially everybody from SEMA, it was actually kind of a running joke that I got a lot of hate at SEMA that my car didn't run, and it was just another one of those SEMA cars that you rolled in and it didn't run. Because the wiring was so clean, because there were so few accessories, and because it just looked like a block. But
it actually did run.
It ran functionally. It drove in there. It drove in my interviews and stuff after. It drives now and it looks exactly the same.
I mean, as they say, haters gonna hate.
Yeah.
But yeah,
Yeah.
proof is in the
Hilarious.
pudding. Let's dive into these headers. So you've got the LS sitting there. You've got a design in your head. What's the process for turning that into reality? And I mean, here you got to be so careful, I can imagine, with an 8-into-1 header design, because it's such an obvious aesthetic element, and getting the symmetry and the mirror image essentially side to side is going to be so key in the final result.
Yep. And actually on the LS in particular, it has offset heads. So the heads are like offset like an inch and an eighth or something between each other. So creating the header and making it look symmetrical was indeed a very big challenge. But I used this, it's called an Ice Engine Works kit. And there are these little plastic clip together blocks that are basically like Legos. And they have different radius bends, but all of them, center line radius is an inch. So I got a V8 kit. I was actually only able to create one side because I had so much straight tube and it was such a long tube design. But I created the one side, taped together all the pieces, recreated the one side with stainless, 304 stainless. And then once I had done that, I basically just did the same thing I did on my tube front end. I pulled the individual runners out, measured what bends I needed to create, created the bends on the other side, and then just tacked them together, rotated opposite.
So hence guaranteeing you've got that mirror image.
Yeah, yeah.
Okay.
And then there is a little bit of kind of play where like before you tack it, you can move the runners around, and just making sure that when you look at it from the front, the collector is straight, it's level, and then the runners are landing at level heights on each side of the engine and level tilts to make it visually look perfect, even though lengthwise and bend-wise, it would be perfect. You just got to check all that to make sure it's just 100% perfect.
Yeah, okay. Material selection for that, so stainless steel, but specifically what grade were you using and why was that chosen?
Yeah, so it is 304 stainless steel. I debated going 321, but 304 just, there was more bend sizes, more sizes of tubing, different bend radiuses that just weren't there in 321. And it's just a very, honestly, easy stainless to weld. I did not need to back purge it, but I did back purge that entire equal length 8-to-1 header when I TIG welded it.
All right, so a couple of things there. First of all, talking about those materials, the 304 versus 321 stainless. 321, I think, is probably more critical for turbo headers, as I understand it. I'm not a metallurgist, but the ability to withstand high temperatures is better with the 321. But as you mentioned there, limited in terms of what you can get, but also, most importantly, quite a lot more money than 304.
Quite a lot more money than 304. I am thankfully sponsored by Vibrant Performance, so mine is a little bit different. I could have gone 321. There just wasn't enough development in different bend radiuses and sizes yet.
Yeah, sure. Okay, so then jumping into this technique of back purging, I'm sure that most people listening probably have a broad understanding of what it is and why we do it, but can you give us a bit of a rundown on back purging?
Yeah, so when you're welding something out of stainless steel, when you weld it and it has no gas on the inside, it gets sugaring. So it has this kind of white texture on the inside of the weld where it's oxidizing. So by back purging it, basically that can create a kind of a weak point. So like if your turbo headers or something have cracked before, it's usually because it's a cheaper header that hasn't been back purged. But basically what you do is you plug the ends, and instead of having one regulator on your gas, you have one regulator going to the torch, and then you have one regulator going inside the tube, and you blow out all the normal air and you fill it with argon.
Okay, so argon is the same gas we use to protect the weld pool, so that gets fed through the TIG torch, and then you're doing exactly the same on the backside, basically removing that atmospheric air, because otherwise, essentially on the back of the weld inside the tube, it's no different than if you tried TIG welding without any gas flowing, correct? It's just going to be a hot mess.
Yeah, it's also just a very thin material, so there's so much of that weld that's hot and exposed on the inside versus like if you're welding roll cage tubing, it's so thick that the actual amount of red like molten metal on the inside is very small compared to the outside.
Yeah. Now, in terms of the collector itself, 8-into-1, there's a lot going on there. Is the collector, the merge collector, something that you fabricated by hand, or is that an off-the-shelf item?
Yeah, so actually the only part on the whole car that I didn't fabricate was the 8-to-1 header, basically where it comes into the 8-to-1 before it like flares back out. There is a company called Stainless Headers. I believe they're in the US, and they can build them in like 2 or 3 day turnarounds, and they're relatively cheap. I think it's like $500 or $600 for a header. They can build them in whatever angle. You could even do 10-to-1, whatever size, and they use special machines for cutting the angles and stuff on the 8-to-1 that saved so much time on my end that it made more sense to go with that, honestly.
Yeah. I can imagine the time that you'd pour into doing that as a one-off. Yeah, it makes sense where you can save that time. Is there any sort of concerns around the manifold expanding with heat? Is there any sort of consideration around allowing it to expand so it's not going to crack? Likewise, is there any flexible joint in that exhaust post collector so that the whole weight of the exhaust system is not being supported on those headers as well?
Yeah, so first off, my header is very unique in the way I've mounted it. The collector is independently mounted from the header, and it has 2 very large, I think they're like 1/2-inch solid stainless support bars that go to the heads. So basically there's 1 bolt in each head, and that supports the whole weight of the collector. So the collector can just sit there on its own. And then each bay, so 4 runners each come into the 4 bays on the collector, and those are supported by their actual flange on the head. So the header is supported by the heads, and then the heads support each section of runners, and it just kind of holds itself there. And then when you take those bolts out, the bolts are what is keeping the collector tensioned onto the runners. So there's no springs, there's nothing like that, but it does have room and slip joints for expansion and contraction. And then after the engine, there's a flex pipe.
Sure. Okay. And because this thing runs so low, the other element, which is quite unique, is your exhaust system as it runs under the car isn't round, is it?
No. So it kind of snakes around. It has the down pipe around the steering column, and then it goes 4-inch, and then it goes 4-inch oval. So the whole length of the underside of the car, almost where the old fuel lines, I believe, were, is a huge 4-inch oval. And then once it gets kind of under the driver compartment of the car, then it separates back into a dual 3-inch.
Okay. And that's an interesting technique for getting or achieving as much ground clearance as you can with a lowered car, which is often a problem when you're trying to fit a large diameter exhaust system. Is it difficult to source oval tube like that, or is this where Vibrant sort of stepped in as well?
Yeah, Vibrant makes all the way up to 4-inch in oval tubing. So it's actually and I believe they've even started making oval tubing bends, vertical and horizontal bends. So there's tons of good resources on that stuff.
So life's just getting easier for fabricators by the day.
Oh yeah, because that didn't even exist. The bends didn't even exist when I was originally making that. So that's like a last year thing.
Yeah, well, okay. I guess if there's demand for it, it makes a lot of sense. I just want to take a moment out of our interview with Cam and talk about a package that's going to be perfectly suited to those of you who are enjoying this interview. Maybe at this stage, listening to Cam's experience and his story, you're thinking to yourself, well, maybe I could have a go at fabrication. And the answer is absolutely, yes, you can. And we do have our ultimate motorsport fabrication package. This includes our motorsport fabrication fundamentals course, which will teach you the basics of fabrication. You'll learn about the welding techniques such as MIG and TIG welding, tube bending and notching. You'll learn about dimple dies, some of the more common techniques that you see used in race car fabrication. You'll learn about the other basic fabrication tools that you will need and how to go about using them. Moving on from this, we are also including our practical TIG welding course. And this course, as its name implies, will teach you the fundamentals of TIG welding. As we learned from Cam's interview, Cam was self-taught looking at YouTube videos. And as I mentioned, that's a great way to learn. However, there's a lot of fiction mixed in with the facts that you're going to need to wade your way through and figure out what's true and what's not. We've taken the hard work out of that for you with our practical TIG welding course, and you'll learn all of the fundamentals of how the TIG welder works, how to set up your machine. Specifically, we've also got cheat sheets in there for machine settings to suit different materials and different thicknesses. And this is incredibly important because, as we mentioned in our interview, getting good quality, strong and attractive TIG welds is part practice in terms of technique on the torch, but the best technique on the torch is going to be absolutely useless if your machine settings aren't right in the first place. So this will fast track your learning. We've then got a simple step-by-step process that you can apply when you are using your TIG welder. This package also gives you 2 years of gold membership, which gives you access to our weekly live members-only webinars. If you can't watch live, you can review these webinars as a gold member in our archive, where we've got over 300 hours of existing content. This is an absolute goldmine to expand your knowledge on a wide range of performance automotive topics. Total value of this package is $755 US. It's normally priced at $299 US. You can, however, use the coupon code CAM100 and that'll get you $100 off. So just $199 US for that package. Amazing value if you want to start your journey learning to fabricate. You are still completely protected by our 60-day no questions asked money back guarantee, even if you use that coupon code though, so absolutely no risk giving these courses a test drive. We'll put a link to that package as well as the coupon code in the show notes. Let's get back to our interview now. Before we move on with the back end of the car, just while we're talking about the engine side of things, what have you got controlling that? What's the electronics package?
So the engine is running off a Haltech Elite 2500. Very simple terminated harness. It is just an engine control module running the engine. It works beautifully. Plug my computer into it. I did the base tune myself. I have gone back through and done some slight adjustments to make it run slightly better. Eventually it will be dyno tuned. I know everybody's mad at me that I haven't done that yet. It is coming, trust me. But yeah, it's a beautiful system and so adaptable and easy to really run any engine on.
Yeah, definitely. It is very flexible. So again, you've developed and added another skill to your repertoire there of engine tuning. So, I mean, you mentioned that maybe it's not fully tuned right now, but sort of how did you work that out?
Well, I mean, I wouldn't give myself too much credit. It is very slight adjustments, like when it's idling too high or it's not getting enough fuel or getting too much fuel. Those type of adjustments just to kind of clean it out and make it just kind of base work. I can't go further than that.
Because with the Elite, you can basically download a base map for an LS3, can't you? So, I mean, it's not going to be perfect. It's kind of designed to get the engine up and running and do some basic systems checks, making sure that it's not leaking fuel or oil, and then you get it to a dyno shop so that the tune can actually be completed. Are you going to undertake that work yourself, or is that something you will leave to a so-called professional?
I know a lot of people have been pushing me to like do a bunch of research on it and learn it just to kind of finish out the whole process with me doing everything. But at this point, I don't feel confident enough to go push a car that hard with having no experience. I feel like somebody needs to do it once on my car. And then when I'm like, I want to do it again, then maybe like I'll have the confidence to do it myself.
Well, I'll let you in on a little secret. We actually have some courses for that, which might be perfect for you. One thing in terms of the tuning side of things, we quite often get asked is, what engine should I start learning to tune on? And the reality is there's no sort of black and white answer to that. You can learn on any engine, but what I find is a lot of people now are trying to get started with their first project being maybe a 2-litre 4-cylinder turbocharged engine that's destined to make 800 horsepower. And I mean, yeah, absolutely, you could get it done, but the tuning envelope for an engine at that power level is going to be very, very narrow. So it's not going to take a lot of mistakes to cause some damage. But the naturally aspirated engines, even at 525 horsepower, the LS3 is not actually that stressed, so it's actually quite an easy engine to tune. I think if you wanted to, but that's a decision only you can make. In terms of the wiring for it, you mentioned there a terminated harness, so this is just an off-the-shelf Haltech harness that you've managed to sort of tuck and get out of the way. You didn't have to do any wiring yourself?
So the base harness is a Haltech harness, but the way that they run it is it goes over the engine and over the fuel rails and then down around the front. And it is very visible. It's very accessible and easy to work on, which mine is not, but it is very visible. And
You didn't want that.
yeah, I didn't want it visible. So mine has been spliced, lengthened in some places significantly, like 20 inches, shortened in other places like 20 inches, so that it kind of goes around the back of the heads and just has the perfect length to just barely make it to every sensor. And the only wires that are visible on that whole thing are the wires going to the fuel injectors. And even those are tucked under the fuel rails. So that's all that goes over the top of the engine.
I can see how people mistook it for an engine with no wiring. It is very clean. A lot of people that I talk to, enthusiasts out there who are prepared to take on just about any element of a project car build, still tend to shy away from wiring. I think it's one of those areas where people tend to get scared off it because obviously you can't see voltage and current. So if you're not really familiar with how wiring works, it can be a little bit difficult to get your head around those concepts. So how do you find that? Just tackle it in your sleep, not a problem?
Yeah, so that was pretty easy. I was like, I'd take the harness apart and I'd be like, okay, these two wires need to stay to those two wires. I can't flip them.
Yeah, I mean, extending and modifying the harness is obviously much easier than starting from scratch.
But that only ran the engine, and my engine only had an alternator on it. So I got radiator fans, I got other sensors running on the car, I got water pump, fuel pumps, all that sort of stuff kind of throughout the car. And all that is running on, I used relays and fuses. It's all very tidy and in a custom made fuse box that I made, but really getting the knowledge of how a relay works, how a fuse works, and what's actually happening there, kind of almost like connecting it to something mechanical and visible. You can get your head around what's happening and what you need to do. And I was quite successful in creating my chassis harness for all of the secondary components that are running the engine.
Yeah, I think one of the elements that makes wiring more manageable, two elements actually. One is thorough planning. And I think a mistake that a lot of people make is that they just jump in with a pair of wire strippers and a crimp tool and get started. And that generally doesn't end that well. So I'll generally spend, when I'm building a harness, I'll spend as much time on the planning stage as I will on the actual construction phase.
Absolutely.
And then I've got a roadmap essentially to follow, so it's pretty easy. And then I've also got documentation for later on. Because the other problem is you come back to this car in a year's time because something's not working or you want to add to it or modify something. And then you sort of scratch your head and spend 20 minutes trying to figure out what the hell you did and how it all works. So if you've got that documentation, it's just a no-brainer. The other part, I think, in terms of simplifying and breaking down the wiring harnesses, rather than sort of getting daunted by the entire chassis harness, let's forget about that. Let's look at an individual circuit. So let's look at the wiring just for your fuel pump or fuel pumps. And if you break that down like that, all right, that's one circuit. We've got that wired. We understand how it works. That job's done. Let's move on. And I mean, really, that's how it all works. In terms of doing this again, if you were to have your time again, would you consider using a power distribution module instead of relays and fuses?
Absolutely. Relays and fuses were the easiest for me to connect to something mechanical. I understood what was happening and I'm like, okay, I can wire this and just make sure I know what's happening. Very simple. I'm like, nothing is going to go wrong there. I only have 8 other components on the car other than the engine. I can handle that and make a very tidy little fuse box. Haltech, another one of my sponsors, was pushing their new unit, which is the Nexus R5 or R3. And it is an ECU and internal power distribution module. And seeing that at different events and how it works, it beautifully simplifies the whole process. At that point in my journey, it was just a little bit out of my wheelhouse because I couldn't connect it to something mechanical and I couldn't figure out exactly what was happening. So doing this stage first, even I could upgrade that car at some point to that system.
There's definitely a crossover when you go from fuses and relays to a PDM, that there's another skill set required, which is kind of not too dissimilar to tuning an engine, because you're going to obviously have to break out the laptop, understand how to set up and configure that. And then there's also complexities. The nice thing with that R5 or R3 is obviously everything being in one box. There's no complexities around, how do we get the signal from the ECU to our external PDM to trigger the fuel pump, and that's normally a CAN message. So that's another layer of complexity. But the R5, obviously everything talks to itself internally, so that makes it nice and simple. So no, I understand that. I mean, certainly there's still nothing wrong with fuses and relays, and they have their place. I think the other element, not such an issue when you're doing everything yourself, but people do get put off power distribution modules because obviously they come at a price point. Thankfully, they've come down massively in price just over probably the last 5 or 6 years. But it's really easy to overlook the amount of time it's going to save you in comparison to wiring up switches, relays, and fuses, because wiring those up and then not only just wiring them, but doing a neat job of it, that is incredibly time consuming. So now we can have this PDM and maybe a CAN-based keypad and everything just sort of plugs together, plays nicely, and it's all nice and easy.
Yeah, and I know Haltech, at the point that I was building my 86, hadn't developed the LS terminated harness to go with it. So any engine that you got an R5 or an R3 for, you had to completely build the engine harness as well. So that step also, it complicated my kind of secondary components, but it massively complicated my engine wiring. And they have a full plug-in LS harness now, of course, after I've built the car, which that would have made me like, okay, I'll take on the challenge, I'll figure it out. But not having the engine harness with it was like, oh, this is way too...
Decision made.
Yeah, that was way too much of a push.
Yeah, okay. All right, so let's get back into the chassis. So we've talked about the sort of the front end and what you've done there and the roll cage. Moving to the rear of the car, what were the modifications necessary? Are you still running the factory 8.6 diff and cross member? That might be a bit marginal at 525 horsepower.
Yeah, so the diff is actually out of an IS300. They take the same mounting point, so you can actually swap in an IS300 for a 86 FRS diff. But the good thing is they're an open diff, and I welded it, and they've been proven in many Pro-Am FD cars to handle like 900 foot-pounds welded.
Oh, wow.
So that was well within what I needed. And then Drive Shaft Shop makes 1100 horsepower chromoly axles. So by getting the 1100 horsepower chromoly axles, the 900 foot-pound rated diff, and then a drive shaft that's rated similar, you have a whole setup that can do double what that engine is going to put out.
Yeah, so that should be bulletproof.
Yeah, and those diffs are like $150 from a junkyard. So if you blow one up, who cares? It's another $150 versus like what I really want to do eventually is like a winter's quick change or something.
Sure. It's interesting. We still run the stock differential in the back of our endurance car, and that's powered by a SR20 VE turbo engine that produces, depending on the boost, up to about 600 wheel horsepower. However, the only reason I think we managed to keep that diff alive is that the endurance racing series that we primarily use the car for is all rolling starts. So yeah, there's not the clutch dump that's really shock loading the differential. And case in point is we do a local hill climb here, which the car's not really built for or competitive for, but we do that. And last year, after about 5 runs, took 3 teeth off the crown wheel and the diff. So maybe the IS300 diff upgrade might be something we should be looking at.
And you definitely have to weld it though, because the spider gears in the IS300 diff are not great. But if you weld and plate them and it all becomes one, the actual main diff gear is perfect.
Yeah, okay, interesting. All right, the key element, I guess, in the back of the car that's a sort of work of art, I guess, is the best way of describing it, is the suspension system. So this is where you sort of went a little bit more elaborate than the front. So talk us through the kind of design principles and why you decided to go the way you did.
Yeah, so just kind of an overview on the actual suspension components first. It's very much like the front. I didn't want to push too far out into complete suspension design out of thin air. So there was very slight adjustments, but the subframe assembly is the same as the factory subframe assembly. The diff has just been raised, and the diff is now solid mounted, and it has all aluminum bushings. All of the arms are now full Heim jointed, like redesigned FDF arms. Again, you could bolt in factory arms. So the whole lower assembly of basically the wheel movement, like camber gain and all that, is going to be the same as the factory car. Where it really changes is it's being held up by a tube chassis, and then above that, it is a fully custom design, like push rod or cantilever suspension, however you want to call it, where it has pivot points, it has rocker arms, and then very uniquely is a bagged cantilever setup. I designed some and like put some parts together to build some custom cantilever capable bags.
So is this through necessity? In other words, did you have to go down this path, or was it more just, again, sort of flexing your creativity and having something that's going to be aesthetically pleasing?
So I would say it's 50-50. A big part of that kind of rear end that most people don't see, and another reason why people didn't think the car would run, is it has a rear mount radiator, but almost every compact car has a rear mount radiator that is tilted like matching the rear seat, and it pulls from the rear window. My rear mount radiator actually has ducting that pulls from the bottom of the car like a trophy truck. So from the top of the car, you can't even see the radiator. It's just funneling air from the bottom and then out the trunk. That created a little bit of a problem with the way the radiator was sitting and tilted back there, where there wasn't a ton of room for shock towers. So by turning the rocker arms and the struts sideways, it gave me a lot more clearance for the radiator setup to sit like that.
Yeah, okay, that makes sense. In terms of that rear radiator setup, I'm interested if you've kind of got enough miles on the car to really prove how well that's working. I'm guessing that might be marginal given that obviously you haven't been to the dyno yet, but why I ask is we see a lot of cars where they've got a rear mounted radiator, which is great for a variety of reasons: weight distribution, giving yourself more room at the front of the car, and obviously with that 8-to-1 collector and exhaust, there's not a lot of space for a radiator left. But often it ends up being problematic in terms of actually keeping the engine cool. So how has that worked out so far?
Yeah, the radiator on its own is a dual pass radiator, so it's pretty good. It's not a super huge core. And down the line, I'm thinking of doing a pretty thick, triple pass radiator to help it out a little bit. It doesn't do terrible. It gets the job done, but it does hover. When you're using the car and driving the car, it does hover at up to 15-ish.
Yeah, okay.
Fahrenheit.
It's up there a little bit.
It's up there a little bit. I would like it to be about 200. I think it's less about how the radiator is pulling, the fans that are on it, and the amount of water in it than just the radiator is a little bit small for the amount of water that's in it.
Yep. Yeah, okay. Fair. Back to the rear suspension setup. So I just want to, again, talk about options that aren't CAD, because, again, I understand you use some pretty basic techniques in terms of modeling all of this and kind of figuring out motion ratios, etc.
Yeah, some redneck engineering.
Redneck engineering, I like that term.
Yeah, so what I did was I built the main support bar for the cantilever suspension, and then I put temporary pivot points for the rocker arms and temporary inner pivot points for the struts. With that, I pulled the springs off some coilover struts, and I created a wood push rod. So it was basically a strip of plywood with a hole at each end, and then a wood rocker arm. And by bolting all these parts together, I could very quickly change the ratio of the rocker arm, the orientation of the rocker arm holes, and the length of the push rod. And by doing this, I could cycle the suspension, test it relatively thoroughly. I mean, I'm not going to be driving the car around, but you can cycle the suspension. You can make sure there's no binding, and it all just functions perfectly in the full motion ratio. And then at that point, you can create the final pivot points, the actual rocker arms, and kind of finalize the whole system.
Yeah, okay. Yeah, that makes sense. Again, just showing that if you're creative enough and you're sort of thinking outside the box, there's always options available. And obviously, it's worked. All right, let's move on. And I want to talk a little bit about the skills that you've developed. Obviously, we've talked about them as we've gone, and we've sort of been highlighting some of the specific elements you've been fabricating. I'm interested, you started this project at 17 years of age and you've just turned 22. I'm guessing that your mindset is maybe a little different to the average late teenager who's probably hanging out with their mates and drinking at bars. I'm guessing you weren't doing a lot of that?
Yeah, really no drinking, just obsessively learning and creating cars. I would say it's almost an addiction to learning new skills. And I like that feeling of being competent. Like if I come up with an idea that's really out there, I like the feeling that like even if I couldn't necessarily do it, I could figure out how to do it. And I have gone from really no skill. Like when I started this process, the kind of the wide body stage, I had never changed oil. I had never done an oil change. I'd never taken a wheel off. I'd never done anything. And just by slowly working up, I'm at the point now where I would say I'm at a professional level, TIG welding, fabricating, like we talked about.
No arguments from me there.
Yeah, like we talked about, some wiring experience. I painted the whole car and wet sanded, cut, and buffed the entire car. So that was a whole learning experience. The little bit of tuning that we talked about. And then like even, I know we were going to talk about plumbing, but plumbing the whole car and just working with engines and all that, it's just been a massive journey of knowledge on a daily basis where I've felt like I've been out of my comfort zone the whole time. And I'm a little terrified, but it's so fun because like every day you learn something new, you use the skill set and you can conquer it eventually, even if it's not perfect on the first shot, you know?
I mean, I think that little bit of fear and being just on the edge of your comfort zone is the place to be if you are going to push yourself, because if you never stretch your ability and move outside of your comfort zone, the reality is it's going to be very hard to develop more skills. Given everything that you've done on this car, and literally you've done everything that you see on the car, what's your sort of favorite elements of the build in terms of the parts that you enjoyed most? And if you would have the flexibility to pay someone to do certain elements of it, what would those be? In other words, what do you hate?
Yeah, so fabrication. I love fabrication. Like if I had to pick a career, I would be an automotive fabricator and welder. Those are my chosen areas and what I always love to do and the art in that. So the chassis, the header, those were the most, actually in particular the header. I built that in 9 days and it was the fastest thing where like I had a vision, I created the vision and then it came to life. And that was honestly the most fun like 2 weeks of the whole project was creating that header. So fab and welding is definitely my favorite part and what I will always be doing on these builds. If I got to the position where I could pay somebody to do a part of the build, it would absolutely be paint. That is paint and body work is so out of my comfort zone and what I even want to be spending my time on. And honestly, the whole body of the car reacted when I painted it the first time because I was painting it in this little, my little storage unit. I put some box fans on the garage door, but I just painted it in my little storage unit and it was 115 Fahrenheit on the day that I painted it. And it was too hot and it like flash cured and reacted the whole car. And I was like, oh my God. And at that moment for it, I was like, I'm going to finish this. I'm going to make this paint SEMA worthy and perfect. But if I have any amount of money, it's going to paint.
100%. Yeah, that mirrors my stance. I mean, when I built my old drag car, I was in a position where I didn't have the money to pay anyone to do anything on it. So I literally did the panel work and the paint, and I swore I will never, ever do that again. I mean, I got a finish that might not have been quite SEMA worthy, but I was absolutely happy with it. But the time that went into it, and, you know, much like you, I kind of painted that car. It was up on some jack stands in my parents' garage, and I kind of wet down the floor to try and keep the dust down. And it's just...
Yep, I did that too.
It's just a whole thing that I still maybe have nightmares about it. It's maybe some, not PTSD's coming back. I need to move on.
Yeah.
Another element there, which we haven't sort of talked about in terms of skill set, is engineering knowledge. And a lot of the people I talk to on this podcast seemingly have a mechanical engineering background, which is a natural progression in some instances, an absolute essential if you want a particular job in the automotive industry. Obviously, you haven't got an engineering degree, but I'm just interested, is there any engineering background, or what did you do in terms of research to know that, when you designed that tube frame front end, that you were going to have the confidence that from a mechanical standpoint, it was as strong, if not stronger than the factory front end?
Yeah, so I mean, there's a lot of people that you can look up to, specifically in the trophy truck scene, where the way that they're designing their tube structures and the way they're tying in, and when you listen to these guys talk, they have some very specific like bits of knowledge where it's like, you never do this. You never have a tube kind of coming into a flat section and just leaving it, like, you don't have open air junctions where you're just putting a tube somewhere and it doesn't displace the forces anywhere. And by listening to these people talk and looking at engineering books and even just looking at reference pictures of time attack race cars and different forms of race car tube chassis, you figure out very quickly that you want to create junctions that have as many tubes coming into that junction as possible. So when I'm thinking about a front end, I'm like, the bare minimum that I want in a junction is like 3 or 4 direction. But if I can create every major junction having like a 5 or 6 direction junction, that is the most ideal. So by creating a tube chassis that comes in and mirrors the force structure of the factory car, and then doing it by creating junctions that all meet up like in 5 or 6 point junctions, and using reference pictures of cars that have worked and been proven before, you can kind of create a design that is, a lot of people say that I used way too many tubes, but you can also cheat it by that, by like designing the base chassis and then being like, I'm going to make it a little bit more artistic, but like adding double the tubes and making it look cooler also helps.
Yeah. I guess where it gets a little bit trickier is when you're designing something not necessarily as an art project, but you're designing it for motorsport, where the key sort of drive is trying to reduce weight. And obviously then you don't want to put in more bars. So it's a case of balancing that up and making sure that you've got the right sort of strength to weight relationship. I 100% agree with you though, looking at what others are doing. So if you look at other forms of professional motorsport and you spend time snapping some photos and looking at like how suspension is designed and what size tube they're using, how many of them they're using, what size rod ends are being used, that gives you a really good guide of like, well, this is a known quantity, it's proven, it's working. So, I can be pretty confident if I follow similar design guidelines, we're probably going to be okay. So I think like it's helpful to have a base understanding of engineering principles. It's good if you can understand the sort of forces that are going to be involved in a particular component, but ultimately an engineering degree certainly isn't a prerequisite for designing these parts in my opinion anyway.
Yeah, and on that, I can say that I went pretty high in math. Like I went all the way through calculus and all the way through like calculus-based physics. So although I am not an engineering degree, I'm actually a business degree, but I did have almost all of the math and physics needed to complete a mechanical engineering degree. And I do go back. Like I always have my graphing calculator at the shop, and that stuff does come up. So whether you're learning it on your own or in a mechanical engineering degree, there is some stuff that you just need to have. You can learn it, but it is necessary.
It sort of comes back to as well, I think a lot of us when we went through school and we're learning math and then sort of calculus, and you're sort of thinking to yourself, probably verbalizing like, why am I learning this? When am I ever going to use this? But lo and behold, sometimes that stuff that you learned at school actually does come in kind of useful. Obviously not for every vocation, but yeah, certainly in the automotive industry, I do find myself using some of the math that I figured was going to be pretty useless. Now, looking at the entire project as it sits right now, if you are being super critical, is there anything that you would change if you were to do it again?
I mean, if I could change slight things right now, there are a couple things, but at the point I built it, it's perfectly done. Like really what I would change is I'd put the bigger radiator in, a bigger triple pass radiator. And eventually, like I said, I want to upgrade to a Winters like quick change rear end or something along those lines. But like those type of things, Like the radiator could have in theory been done when I built the car, but like the diff, that's just such a huge monetary difference that it made more sense to go that direction at that point.
I mean, those are also very minor things. It sounds like obviously you're completely comfortable with the fundamentals of the car and the design that you've got, which is absolutely great. I, on the other hand, always kind of build something and then have regrets and wish I'd gone in a different route. So maybe I just need to learn to sit back and just be happy with what I've created and leave it as it is. When it comes to setting up a fabrication shop, again, I think a lot of people think that they need to spend tens of thousands of dollars on fabrication equipment. And I mean, obviously, there is an element of like, what do you want to make? How big do you want to make things? And that's going to drive the tools you'll need and the cost of them. But I'm interested, I'm guessing that you didn't start out by dumping sort of 50 grand into high-end equipment. You've already talked about sort of the frugal approach to your TIG welder. So yeah, can you talk us through what you consider to be essential equipment for fabrication?
Yeah, so I have a little cart that I kind of like roll around, and it has the tools that I pretty much use on a daily basis. And those are the tools that really are necessary. So what I have is the tube bender. That's the big one. Tube notcher, which you don't actually need. You can do that with an angle grinder. It just makes it more precise. I have a press brake, which is probably the biggest, most complicated tool for sheet metal bending. A bench mounted belt sander for squaring up and grinding your stainless tubes and stuff for exhaust fabrication. And then a variety of like handheld 4.5-inch angle grinders. I think I have like 5 of them, all from Harbor Freight, and they have all my different attachments. And then I have an orbital sander that I use for finishing metal before I weld it, a angle die grinder, a straight die grinder, a air like cutter wheel, and an air saw, and then an air belt sander. And that right there are my fab tools. That's what I use to build everything.
I mean, obviously you've just listed a reasonable number of tools, but each in their own right, it doesn't sound like any of them are overly expensive. Maybe the press brake, but you got an idea, just a ballpark figure of what you've got invested in tools for fabrication at this point?
Yeah, so we talked about the welder, I would say the most expensive things on there, like none of those little tools that I mentioned were over $50. So say average out all those little tools are $50 a piece. So, the angle grinders were $16, but the press brake was the most expensive. It was like $400. And then the little bench like belt sander, I think was like $100. So, we're maybe talking for the whole lot, maybe $3,500 to get in and be able to fabricate like at my level.
So hopefully what I'm hoping that this conversation has got to is that those listening who have been making excuses for why they can't do fabrication work on their car, hopefully we've broken down some of those reasons, and $3,500 is not a massive amount of money, and particularly I'm guessing as well you don't dump that money in all in one go. You generally will start with some base tools, and then as your skills progress and you need different tools, you can start adding to that collection. So it absolutely should be affordable. Most people are probably spending more on a set of aftermarket wheels for their project car than you've got invested in tools. All right, another element I want to discuss here, which we haven't really talked about on this podcast before, is sponsorship. And I don't want to go too deep into it, but it is worth just touching on here because I know that you were quite fortunate that you managed to pick up a number of sponsors to help finish the car for SEMA. I think these days a lot of people kind of think that sponsorship is a given right and it's a very one-way street, and their approach to companies to try and get sponsorship is kind of a little bit skewed, and it's all about what the company can give to the person as opposed to this being a two-way street and what can be given in return. So I'm just wondering if you could give us a bit of a rundown on your approach to getting sponsors, and then just as importantly, keeping those sponsors happy, giving back to them.
So the first thing is you need to have value. There is a million people on this planet that want free parts and want to build a whole car for free. That's not going to happen. All of these companies are functioning businesses, and they're not going to just give you free stuff. So you need to figure out how to make yourself desirable. I did that by building up a social media following and building a brand image that people can connect with. So before I even reached out to a single sponsor, I had purchased the engine, purchased the transmission, and built an entire chassis and cantilever rear end, had the engine in there. So the project was already a presentable piece. It was a chassis, it was a cage, it was the engine setup. And I had grown my Instagram to over 100,000 followers. So I'm coming into the game with a project that, in the eyes of most people, could very easily be completed because they have to be able to see the vision. And the Instagram following alone is a very, or whatever social media you want to use, YouTube or that, is a very valuable asset. So by getting that social media following, having a project that you can see value in, and then I actually had a professional 3D rendering done of the completed car in different forms because I had a very artistic vision that I didn't feel like could be communicated over words from what I had at that point. So with the car being where it was, the rendering, and then me writing very in-depth like portfolios of what I had done, what I was planning to do, and then a official proposal of like, here's what I'm going to do with my Instagram to promote the company. Here's what I'm going to do with my event schedule, with the car, like branding on the car, whatever you want to do with it, to create more value to the company than they're going to give you in parts. You need to prove to them, like, if they're going to give you $5,000 in parts, you need to prove to them that there's going to be a over 100% return given. And when they can see that, and they can see that it fills a niche that they don't really have anybody that fills, like mine is a very artistic style that has like a different presence, and the way I present, and then that kind of leads into how to keep them happy. So when that all works and they're like, okay, I see the vision, we can get behind this and we can help you. I'm very specific about if there's any other companies on my car that weren't sponsored, I take the brands off. So I don't show the brands on those parts. And then I make everything else around the part that they've given me on the car very simple. And they always have branding. So the parts that were sponsored on my car are always very visible. And like they're the standout elements. So each part of the car is a promotional tool for that company. And then just following through. Like if you say you're going to go to SEMA and reveal a car in Toyo Tread Pass and then compete and battle the builders, you got to do that. And by doing all those things, I made all those companies very happy. And I know that.
Yeah, absolutely. I mean, I think there's too many people out there who sort of have 28 followers on Instagram and haven't even got a car and sort of approach a whole bunch of companies with their hand out expecting money or parts. And the world unfortunately doesn't work like that, or maybe fortunately doesn't work like that. You really have to actually prove that you're worth it and that you've got something to give. But the other element which you just mentioned there, I think, is staying good to your word, basically doing the things that you say you'll do, because it's really easy when you're writing a sponsorship proposal to put in an elaborate list of all these things you're going to achieve and do and give back to the company. And then when that sponsorship proposal is actually accepted and they go through with it, well, now it's up to you to actually deliver, because you can guarantee if you don't deliver, it's going to be a one-time deal. You're not going to get a continual relationship with that particular company. And I think that's the element that's really important with sponsorship, is don't view it as a one-time thing. Like, you want to try and build up a relationship that you can foster over time and continue to give value to that company, and then they'll continue to support you because, of course, like most people, it's probably not a one-off project, and you're going to move on and do other things that also need support, correct?
Yeah, and there's a reputation that gets built around you. So if you're going for only big companies, a lot of people that are big in the car scene have a lot of the same sponsors, and these companies have worked together on projects before. So when you get one of these big sponsors and you really pull through and you really promote the company to 100% of your ability and your word, that company is going to be like, okay, well, this kid did that. Like when somebody else asks about this kid, we're going to tell them that he did it or he didn't do it. And that's going to lead to other big companies coming on board. And you just get in this cycle of, if you're constantly true to your word and following through on promoting these companies will talk, and you can get a bunch more companies on board. And I think that's the biggest key thing there.
Yep, Yeah, no, that makes a lot of sense. All right, let's move on. We'll start wrapping this thing up, and we've got the same 3 questions that I ask all of our guests, and these are going to be interesting. The first of those is, what's next in the future for you? And I am interested to see what this adventure is going to lead to. It looks to me like you're in a perfect position to set out on an automotive fabrication business. Is that where you want to head?
So I know a lot of people want me to do that. They would love to have a Cam Kokalis built car, but I am actually not planning to open any sort of fabrication shop or anything. I'm working right now to kind of solidify my roster of sponsors and get funding to be able to build about 2 or 3 more cars at a similar level where I'm able to push the boundaries and create real art pieces that stand out in the industry and can really do something and promote my name in these companies. And then once I've kind of run my course on the artistic element, I at least want to take a small break and focus it into automotive parts design and manufacturing. So, like creating like bolt-in cantilever rear ends for factory cars and parts like that, where it's based on stuff I've built, but it's applicable to my followers' cars so they can relate and kind of have a piece of what I'm building at a big scale.
I mean, that probably makes a lot of business sense. I'm interested why, with the clear passion you've got for fabrication, that you wouldn't just go down the what I guess would be seen as the more obvious and simple path of just becoming an automotive fabricator.
Yeah, so I have a lot of passion for it, but the passion is only there when I'm pushing the limits and I'm able to be 100% like artistically free, if that makes sense. So if I was building other people's projects, there would always be some sort of limit, whether that's budget or whether that's how it needs to function for whatever race it's going to do or whatever it is. There's going to be a set of guidelines that I need to follow. And I don't want to be in a position where I have to follow those guidelines, where if I mass produce parts, I can do this and I can mass produce parts. But both of those things, I have 100% design freedom. I can design the parts however I want, and I can design the cars however I want. And by only doing personal projects and then using the business to kind of keep the cycle going and use the business to fund it, use the cars to promote the business, it's going to create this cycle where I can be artistically free and it also works from a business sense.
Yeah, that makes a lot of sense. I think the other element that a lot of people fall into when they start automotive businesses is they start a business because they like fabrication, for example. And then all of those things that you just mentioned, when you're dealing with customers, there's always constraints that are out of your control, budget or what the function of the part must do or race series rules, whatever that might be, that kind of constrain you. And I think what happens is over time, you kind of lose that passion for fabrication or whatever it is you're actually doing at the time because you're doing it for customers. And then you kind of find that you're less enthusiastic about doing your own stuff after hours or in weekends. So I think it's really important to make sure that you don't lose that passion. And I think the mass-produced parts, obviously, if you find that right niche and make the right parts, that is definitely a good business model for something that's going to be financially viable. Because the other thing is with custom fabrication, I mean, it is a stupidly time-consuming process to get a result. Like you said, with your headers, 9 days of work. And I mean, the problem is if you're doing that for a customer, 9 days of labor plus all of the parts, I mean, that's not a $1,200 set of headers. And, you know, finding the customer that's prepared to pay what that job is worth, I mean, they are out there, but unfortunately they are few and far between. So yeah, all power to you. Right, next question is a bit of a tricky one because the question is, what advice would you give to a younger version of yourself to help reach where you are today in your career faster? I mean, let's be honest, you're 22. I don't think you could have rushed this through much quicker, but is there anything looking back that you would have done differently? Maybe any pitfalls that you could have avoided?
Well, I mean, we had talked about learning CAD sooner.
Sure. Yeah, it's a good point.
I think that really is a big one to save some time. But honestly, everything was done so strategically with growing the following, getting the sponsors, and doing it in a way that it really leads to a career, whether I wanted to be a fabricator or a business owner. The way I did it will lead to a career. And it worked. That car did what it needed to do. It got well known. It got my name out there, and it was a perfect portfolio of every bit of work that I could do at that point. It developed my skill set. I would say I have a good skill set of everything that's needed to build a car. And because of that, honestly, I don't think there's anything that I would change. I did it as concise and accurately I felt like as I could.
I think I'd agree. It was sort of a tongue-in-cheek question, really, given what you've achieved in such a short amount of time. But yeah, I mean, again, hats off to you. That it's incredible what you've built and the skill set that you have built up in a relatively short amount of time. Just on the note of the car as a billboard for your work as well, I think this is a valid direction to go in, because talk is cheap. But when you've actually got a real life running car, that's kind of a business card that you can't really put a price on. And I mean, my own career path kind of was very similar in terms of I built up a Mitsubishi Evo 3 drag car, and I did almost all of the work on that myself, except for the fabrication. I didn't have that skill set. Lent on a really good friend of mine for that side of things. But we went out and we set world records with that car. So it gained international notoriety, and that helped my business at the time. But it's also become the springboard for High Performance Academy as it stands today. So at the time, I was sort of paying myself less than minimum wage probably, and working 80, 90-hour weeks on this stupid car, and I'm driving around in a car that probably at the time was worth a reasonable 3-bedroom house in the suburbs, and thinking to myself, this is ridiculous. But I mean, looking back now, what price could I actually put on it? It did exactly what I intended to do. So it is a very viable way of springboarding yourself into the public eye, and you've got proven runs on the board. Last question for today, Cam. If people want to find you, see what you're up to, have a look at this car that we've just been talking about for the last hour and a half, how are they best to do so?
You can follow me on Instagram at cam.cocalis. I have a YouTube. It's just Cam Cocalis. I haven't really posted any videos, but there's a lot of my interviews and stuff linked on that YouTube channel. Hopefully I will be posting soon. But yeah, it was awesome to get into this.
Yeah, great. Well, we'll put, as usual, links to those social media accounts in the show notes to make it super easy for people to find. But pleasure to catch up and have a chat. It is a car build that I followed. We intended to catch up at SEMA, and it never really happened. But nice to actually do it on the podcast anyway. Yeah, incredibly talented. So again, hats off to you and what you've achieved. And I do look forward to seeing what the future holds for you. All the best.
All right, thank you.
If you enjoyed this episode of Tuned In with Cam, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that, in turn, helps us to continue to get more high-quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Stuart Emirate from the United Kingdom, who has said, thoroughly enjoyed the 2.5 hours with Ben Diggles this week, another in a long line of brilliant guests. Every week there is something that I can take away from the pod, whether it be validating something that I already do or introducing a new view or topic. Andre is a great host, and you can sense his enjoyment through the interview. Great work, keep it up. Well, thanks for the kind words there, Stuart, and I'm really happy to hear that you're enjoying the content we're putting out. If you get in touch with the team with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.